In this video, we're going to review a topic called significant figures. Your lesson objectives are to identify the precision of a measuring device and also to identify the amount of significant figures in a given number. So the reason we use significant figures is because a scientist's final calculation can only be as precise as their least precise measurement. So whichever one is the least accurate, has the least amount of marks on it, that makes all measurements after that not as accurate and not as precise. So count digits in your measured number to determine if what their level of precision is so we can compare precisions. So in this case, we're going to look at the known digits and then plus a final estimated digit so we can figure out the precision of this measurement. So since you can see the 1, 2, 3 centimeters, and you can also see the 0.1, 0.2, 0.3 centimeters, we know it's somewhere between 3.2 and 3.3 where that little mark is, right? So what I want to say for me is because I think it's on the line, I might say it's 3.20. Other students might think it's a little bit past the line and write 3.21. And a few might think it's a little before the line and say 3.19. They all round to the same number, and you'll see that that last digit is variable, right? An estimated digit. So everybody agrees it's somewhere around 3.2, but we're getting 3.20 on the line, 3.21 over the line, or 3.19 before the line, depending on your vision. You should really line up your vision exactly to where the mark is and not come up from behind, up high or down low or from the right side of your ruler. So another example, I'm going to do this one again, and then I'm going to see if you can do the same. This ruler has centimeters, but they're not little marks, there's only the big marks. Remember, this one had a lot of little marks, this one has only marks at the tens. So they're marked at the tens place, so you have to read to the ones place. So when I look at this measurement, I might say that it's 67, right, because I think it's a little more than half. I actually think it might be more like 65, and both of those would be marked correct because you read between 60 and 70, and you said it was somewhere between those by giving that tens place. And on the second device, this one's a little bit more precise because it's measuring the 0.1, the 0.2, the 0.3, so we're getting more decimal places. And it's marked at the tens place, so you're going to read to the hundredths place. In this case, maybe I think it's 0.48 centimeters. Maybe you think it's 0.47 centimeters. That's an estimated value that we have marked with an underline. You don't have to do that. I'm just pointing out that that might vary, but we all agree it's between 0.4 and 0.5. We want to say how much further along is it from 0.4 to 0.5 by marking the hundredths place. So what we want to do is see if you can try it with a cylinder. And then together we'll check our work. So I'm thinking I see 6s and 7s, not only that, I see 6.1, 2, 3, 4, 5, 6. I think we all agree it's somewhere around there. What you're looking at is the bottom of the meniscus, or the part where it's the lowest peak, like the lowest plummet, right? In that case, I think it's 6.60, so I would write a 0 to show that it's on the line. Some might argue it's 6.61. That's okay too. But you're reading it to the hundredths place. So now what you're going to do is the same thing. See if you can answer this Edpuzzle question to tell me what the volume in the graduated cylinder is in milliliters. I got 2.65. So let's see, can you identify the precision of a measuring device? We're going to move on to rules for counting the sig figs. So once you've read a device for how many numbers it shows, you're going to count how many numbers it really has. I know that sounds easy, but there's a 0 part that's a little tricky. So all natural numbers between 1 and 9 count once. For example, 569 has 3 sig figs, and 3.456 has 4 sig figs. But the zeros have specific rules that I would recommend writing down. Zeros always count if they're trapped between natural numbers. So 109, the zero is in the hundredths place, the tens place, and it's really important that we know that that was measured. So it has 3 sig figs, and 50,089 has 5 sig figs. The zeros are measured in the hundreds and thousands place. Here's where it gets tricky. Zeros before a decimal and a natural number such as 1 through 9 never count. So 0.00789 only has 3 sig figs. That's the 7, 8, and 9. And 0.01234 has 4 sig figs. That's the 1, 2, 3, 4. The zeros in the front don't count because they're placeholders. In other words, if you change the first number to scientific notation, it would be 7.89 times 10 to the minus 3, where the zeros go if you're looking at just the base number. Or if that was grams and I changed it to milligrams, it would be 7.89 milligrams. And again, the zeros are gone. And the same thing can happen if that second number was 0.01234 liters and I changed it to milliliters, I would get 12.34 milliliters and the zeros were gone. Those zeros are just telling you the number is really small. And our last rule is zeros after a natural number only count if there's a decimal present. So in 114.20, all those numbers count. We have 5 numbers. And that's because we wouldn't have wrote the 0 in the hundredths place if it didn't get measured. Maybe it got measured on a balance and was reported on the balance. Maybe it was measured because you thought that on a graduated cylinder or a ruler, the mark landed on the line and it was measured to be on the line. So that 0 was written to show how accurate that device was. Whereas 11,420 only has 4 sig figs. Without the decimal, I don't know if that was 11,419 round up or 11,421 round down, or if it really was 11,420 on the line, because I don't have a decimal to show me that was measured. So I'm assuming that they rounded to 11,420 and not had 11,415, right? So the 4 numbers in the front count, the 0 does it without a decimal. Let's practice by recapping. What you should do is start counting from the left to the right at the first natural number. You're going to find the number between 1 and 9 and count to the right. If there's a decimal point present, you're going to count any trailing zeros after the last number, so anything at the right. If the decimal is not present, don't count any trailing zeros after the last number. So in the example that I'm going to do, I'm just going to read through the numbers and tell you how many I think I have, and then you're going to repeat that with new numbers. The number 2,545.300 grams was all measured, or else I wouldn't have wrote those zeros. I believe that there are 7 significant figures because the decimal is present. I started at the 2 and counted all the way to the right. In the number 4,530, I don't know if that was rounded to 30, so I'm going to say that only has 3 sig figs. I counted from the 4, read to the right, but there was no decimal, so I didn't count the 0. In the 0.00453 meters, I think there's only 3 sig figs, because the 0 in the front could be eliminated if I change it to scientific notation or change it to something like millimeters. Also because we're starting at the whole number 4 and we're reading to the right, 453. And our last number, we're only going to look at the base number, 6.23. So that number has 3 sig figs. The times 10 to the 6 just shows us it's a very big number. It doesn't count as your sig figs. You're looking at the number before the times. So I'm going to ask that you do the same thing. How many significant, well, we're going to do it together. How many significant figures were in the next measurement? So I'm going to give you a minute to think. And then 43.40, I think it has 4 sig figs because I counted from the right, the 4 to the right, 4340, the 0 counted with the decimal. In other words, 43.40 with a decimal shows that I measured that 0. So now I want you to answer this Ed puzzle question. How many significant figures are in the following measurement? Now check your understanding. I think there are 4 sig figs, starting at the 4 and counting to the right, counting the last 0 because the decimal is present. I don't count the first zeros, I only count the last zeros. At this point, we want to know if you can identify the amount of sig figs in a number. And remember, we also talked about the precision of a measuring device, along with counting the amount of sig figs in a number, and you should be able to do that now.